theoretical probability. Now this is just what we usually call probability. Now if we took an experiment that had an equal number of or a possibility where there is an equal chance of getting any outcome, we call that this is equally likely. So for instance, if we had a coin and we know that we only have a heads or a tails, there's two possible outcomes. In other words, our sample set would be heads and tails. We know that there is an equal chance if I flip this that I would get a head or a tail. So we call this, if something is equally likely, we call this fair. Kind of like when you are playing a game or running a race, you want things to be fair. In other words, you want to have an equal chance of obtaining the outcome. So in a race, if the person running the race let another student start 2 seconds before you, that would not be fair. There is not an equal opportunity for you to go across the finish line ahead of the other student. So we want it to be fair. We want everybody to start the same way. We want an equal number. Like if this had 3 sides and 2 of them were heads and 1 was tail, that would not be fair. That would not be equally likely. All right, so what we do is when we talk about probability, we usually use a capital letter P. Now, you might say, wait, we use a capital letter P for perimeter. That is true. But in probability, we also follow it up with a set of parentheses. So in this case of our experiment of flipping pennies, what is the probability that we would get a head? Right? Probability of a head. So what we do is it's usually written as either a fraction, a decimal, or a percentage. Let's do fractions first. So what we do is we say that the numerator is the number of ways it can be a success over total outcomes. Okay. The number of ways it can be a success over the number of outcomes. So in the coin flipping, if I want the probability of a head, there's only one way I can get a head. So my numerator is 1. The total number of outcomes, heads or tails, would be 2. The probability of getting a head is 1/2. Or we could change that to a decimal, 0.5, or we could say 50%. Now let's look at another experiment. We have a spinner, and it's divided into 4 equal quadrants. Each one is a different color, red, blue, green, and orange. What is the probability of it landing on green, my favorite color? Okay. So what we do is we create a fraction. On the denominator, it is the number of total possible outcomes. So in this case, there's 4. Yes, it could end up on a line, but let's pretend it doesn't end up on a line. So we have 4 different colors it could land on. Now, the way we could, then we use, what are the successes? So there is only one way it could be a success. The probability of ending on a green, 1 chance out of 4. We can also write that as a decimal, 0.25 or 25%. Now, let's take this same experiment. What's the probability that it does not land on a green? So we could say the probability that it is not green. So we have this, the denominator is the same. The denominator is the same, 4. There's 4 equal chances of getting on a color. Now, how many chances would it be not green? Well, it's everything except green. So that means we have red, blue, and orange. We have 3 possibilities. So in this case, the probability of not green is 3/4, which is 0.75, which is 75%. Now look at this. The probability of green and the probability of not green, 1/4 and 3/4. If you add those together, it equals 1. We call that the complement. Now, we've heard that word before, complementary angles. Okay, a little bit different. The complement in probability is kind of the probability of the opposite happening on an experiment. So the probability of green is 1/4. The probability of not green is 3/4. There is theoretical probability. Now go practice.